Okay, so with butyl, you have actually four different variations that they can come in. So remember, butyl is a four carbon branch. So when the four carbons are just kind of in a row, right, attached at carbon one, it's just butyl. Okay, I know this says N-butyl. Just by putting butyl, that means automatically carbon one. Isobutyl is where you have one carbon and then three. So it's almost like, imagine this was gone, it would be like an isopropyl, but you have four carbons. So there's an extra carbon there, isobutyl. S-butyl is attached at the second carbon. So instead of carbon one, it's attached to the second carbon. And T-butyl is where you have one, two, three. It's attached in the middle, and then there's an additional carbon. So T-butyl stands for tertiary butyl, but you would just say T-butyl. Okay, so taking a look at this here. So here again, we have a cyclopentane. This first example is 1, 2, 3, 4. So this is just a regular butyl. So here you would say butyl cyclopentane. Here we have an S-butyl. See how it's 1, 2, 3, 4. It's attached to the second carbon. So here you would say S-butyl cyclopentane. Here we have an isobutyl. So it's 1 and then the 3 attached in the middle. So this is isobutyl cyclopentane. And then here is our T-butyl. So you can see it's 1, 2, 3, and then a carbon. So if you have a special case of these branches, so if it's a S-butyl, you cannot just call this butyl. You'd have to say S-butyl. Another thing to keep in mind is in terms of alphabetical order, the prefixes for the special namings don't count. So for example, isobutyl, you go by the B for alphabetical order, not the I. Okay, so double bonds. So double bonds, we now have the ending E-N-E. Okay, so E-N-E, so for example, ethene. Okay, if there is more than one double bond, we would have to change it to diene. Okay, and just like you would name, put a number for the branch, we're also going to put a number to say where the double bond is. So if you have two double bonds in your structure, you would have to have two numbers because it's now a diene. If there was three double bonds, then you would have to have three different numbers, and it would be triene. Okay, so for example, here we have ethene, here we have propene. Okay, so it's 1, 2, 3, and there's a double bond. Now, as soon as you have more options, so the reason why there's no number for ethene or propene is simply because there's only one spot that it could be. So for example, here, there's literally only one spot. For propene, if it's here or here, it's still at the beginning of your structure. So this would be like carbon 1. If you were to flip it, put the double bond here, this would be carbon 1. So just like when you're numbering your carbons, you number closest to a branch. In this case, if you have a double or a triple bond that works the same way, you start counting to the side closest to your double bond or triple bond. Okay, so like the side that has the lowest numbers. Double bonds and triple bonds take priority over a branch, like an alkyl branch. So for example, if I have a propyl branch, but I have a double bond, I start closest to the double bond. That propyl branch is not prioritized anymore. So in this case, butene, right? We have 1, 2, 3, 4. We would start counting with number 1 on this side because it's closest to the double bond. So another thing to keep in mind is the number that you report is the first carbon that the bond begins with. So technically the bond is like in between carbon 1 and carbon 2. You would only report carbon 1. It is automatically assumed that it has to be a double bond with carbon 2. So this is 1-butene. In this case, if you take a look, right, the double bond is now starting at carbon 2 onto carbon 3. So here you would just say 2-butene. So meaning on carbon 2 is where that double bond is beginning. It is automatically assumed that it's continuing on with carbon 3. If you have more than one double bond, and the same works for triple bonds, you do need one number per bond. So if you check this out, 1, 2, 3, 4, or works the same way, the opposite. So carbon 1 is the first start of the double bond. So 1, 2, 3 is the start of the next. So this is 1,3-butadiene. So notice now we're putting the diene. If there were 3 triple bonds, you would need double bonds, you would need 3 numbers, and this would say triene. Okay, so the rules start to become very familiar. Like anytime you have more than one thing, you add in a di prefix. If you have 3 things, it's a tri. You always need a number. If you're indicating something is there, you need to have a number to say, well, where is it? Triple bonds literally work in the same way. Okay, it's just that the ending is now YNE, so alkyne. So here we have propyne, YNE. So again, there's no number here because this triple bond, even if it was here, it's still only the same location, like it's number 1. Here we have 1, 2, 3, 4, 2-butyne. So 1, 2, it's automatically assumed that it's continuing on like in between carbon 2 and 3. You only put the first number. And here we have 1, 2, 3, 4, 5, 2-pentyne. So you're saying on carbon 2 is where that triple bond is beginning. So same thing. If you have 2 triple bonds, it would be diene, and you would need 2 numbers. If you have 3 of them, you would need triene. Like it works the same. They are identical in how they are worked. It's just one is ENE, one is YNE. Okay, so here's an example. So here we have a double bond and a branch. So now you want to number closest to the double bond. So meaning, even though this branch is closer to the left side, double bonds and triple bonds take priority over carbon branches now. So we almost forget about that when we're numbering. This is carbon 1 because it's closest to the double bond. So this is 1, 2, 3, 4. So 1, 2, 3, 4. On carbon 3, there is a methyl group. And then you would have to number where on that butene is the double bond. So it's 3-methyl-1-butene. So you're saying there are 4 carbons, right? There is a double bond starting on carbon 1, and on carbon 3 there is a 1 carbon branch. Okay, it's like writing a map. Now, if you were to draw a structure, sometimes I find drawing structures is actually easier because you literally, once you know what all the prefixes and suffixes mean, you're literally just drawing that out. So here we have 2-methyl-1,3-pentadiene. Okay, so let's take a look at that. Okay, so we have 2-methyl-1,3-pentadiene. You always want to start with the carbon parent. So we're going to have 5. So I'm going to show you with the regular structure and then with the carbon skeleton. So we have 1, 2, 3, 4, 5. Okay, on carbon 1, there is a double bond. So we'll put a double bond in. So on carbon 1, there's a double bond, and carbon 3, there's also. So it's 1, 2, 3. Here's our next double bond. Okay, so we've taken care of the parent. And on carbon 2, there is a methyl group. So you can either write CH3 or put a C with the ticks. So once you're done that, you have to make sure you go in and fill in your bonds. So notice this is full with 4, so I don't have to give another one there. So everyone that needs a hydrogen to fulfill its octet there, it's automatically assumed it is a hydrocarbon, so it is full of hydrogens where needed. So as a carbon skeleton, how this would look would be 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. On carbon 1, there is a double bond, and on carbon 3, 1, 2, 3, there is a double bond. And on the second carbon, there is a methyl group. Okay, that means exactly the same thing. Now, one thing I haven't mentioned is for cyclobranches. Give me a second here, I'll set that up. Okay, so if you have a cyclo group, so meaning, let's do a cyclopropane. So let's say you have a ring structure or a cyclostructure, so meaning they're kind of connected together in a shape. So for example, if I have here, so this would be like a cyclopropane because of the 3. This is a cyclobutane. Whenever you have a branch, okay, so let's say I had a CH3 branch here. Okay, if you have a branch coming off of a cyclic structure, you actually always assume that the branch is carbon number 1. Because remember that this has really, it's not like a chain. It doesn't have a beginning. It doesn't have an end. So the actual carbon that has the branch is always carbon 1. So you don't really even need to number it. You can choose to number it. Like if you said 1 methyl cyclopropane, that is correct. But even if you just said methyl cyclopropane, right? So methyl cyclopropane, geez. Right? Methyl cyclopropane would be correct. Or if you put 1 methyl cyclopropane, also correct. The only time it's actually necessary to put numbers when you're dealing with a cyclic structure is if you have more than 1 branch. So for example, let's say all of a sudden I now have, let's say I had another methyl coming off of the same one. So now I would have to say 1, 1 dimethyl. And this would be the same. So I have to indicate that there are 2 methyls on the exact same carbon point, right? If they're on opposite ones, you would do 1, 1, 2. So branches do not need to have a number unless you have more than 1 on a cyclic structure. So let's say I had a methyl group here, or let's make this an isopropyl. So see how I have 1, 2, 3, but it's in the middle. So all I would have to say here is isopropyl cyclobutane. So cyclobutane meaning 4 connected together, and the isopropyl means you have a branch. This is automatically assumed to be carbon 1. Okay, so aromatic hydrocarbons. So this is where we have that benzene again. So a little bit different in terms of naming. So again, this will read through this, but this will talk about the reason why they are very stable, right? So we have pi bonds that are equal distance from each of the carbons. So you have that delocalization of the electrons. So here are actually the 3 representations. So you can use a circle, you can use the alternating lines, or you can draw the full out carbons with the hydrogens. Now when you are naming them, okay, so typically the parent is the parent, typically the benzene ring is considered to be the parent. So meaning your benzene is your parent, and anything connecting off of the benzene would be considered to be a branch. Okay, so let's say we were to do a benzene here. Let's say I have a methyl, right? So this would just be methylbenzene, done. Okay, or let's say I make this into 1, 2, 3, a butyl. So this would be butyl benzene, right? So this guy here is the parent and this is the branch. Now, if you have 2 branches on a benzene, they can sometimes take on a different way of naming, just to add, a little bit more to this.